We wanted to test running OpenShift with a more modern kernel, so we decided to put RHEL9 kernel in an OpenShift installation and do some testing on it and see that everything works properly or not. The easiest way that we found to do it was to just install the RPMs in the nodes. The more orthodox way will be to craft an OpenShift release, but this will make that we have to craft a new release per each version that we want to test. So by installing the RPMs, we can just install the cluster and then run the script that upgrades the kernel and run whichever test that we want. So we can do it very easily. We saw a script that is in CNF features deploy repository from Openshift KNI that is already doing this. It's using a daemonset to install custom RPMs in the nodes, and we base heavily in that work. So I'll show you how we did. We already have here a running cluster. Well, this is the version of the kernel in each of the nodes. And well, we will have a config map with the script that actually does the upgrading, and then we will mount this config map from the daemonset, and we will run the daemonset. Let's go for it. So we just decide which are the packages that we want to install. This is the version that we, well, somehow auto-discovered. That is the latest version that is there in this repo. We need to label the namespace to remove some warnings that will appear. And also we need to add a security context to the default service account here. So let's go for the config map. Let's see it with a little bit more colors. Okay, so well, this is nothing much fancy. I mean, we create a log file that we will be using to see if this RPM has been, well, this like release of RPMs has been installed or not in the node to prevent reinstalling. And well, we just fetch the different packages, we install them, and we reboot the system. So let's apply this config map. And let's get the config map ID that we will be using as an environment variable for the daemonset. Indeed, it is what we use for knowing if the, well, we can see here, it's what we use to see if we install this configuration or not. So let's create the daemonset. Let's see it. And well, in the end, here we are mounting a couple of volumes. One of them is the root of the host. And we are running the script that is copying the script into the host file system and then running it inside of the change root. So well, let's apply this daemonset. We see that the pods are being created, so this is going now. By the way, we run this in all the nodes, masters and workers. And since we are doing it all at once, we can expect that at some point we will lose the connectivity with Kubernetes API until it reboots. You can see here the logs. And well, now it's just waiting for the RPMs to be installed and the nodes rebooted. Well, after waiting for a while, let's see if the nodes restarted and everything is working properly. Okay, this is working. Let's see, cluster operators. Okay, everything up and running. We can see the cluster version is still the same. And let's see if there are still pods waiting for, everything is running already. So now we can just check that the kernel in the nodes have been upgraded. We show that it's very easy to just replace the kernel and everything stays working.